Hey, welcome back to your favorite technical math class. We're going to take a look at the slope of a line. We discussed linear equations last time, but if we talk about slopes, that's talking about the steepness of the graph. And so if you notice here, you can tell that that line is steeper. In other words, has a larger slope than that pink line, right? So different steepness. How we measure steepness of a line is with the slope formula. So m is for slope, and they think that comes from the French word monter, which means to climb. And it's the vertical change in y over the change in x. In other words, the difference in the y values, right? This is your how much you're rising, in other words, a vertical change, and this is how much you're running, your horizontal change. So it's the ratio. That tells you the steepness. So you want to use that slope y2 minus y1. So if you're given 2 points, such as 4, -2, and -1, 5, right? You can see the line goes down on that. You just go ahead and you can name them x1, y1, x2, y2, and you can find using the slope formula, y2 minus y1 over x2 minus x1. You could just plug it in. Your y2 here is the 5 minus the y1 is -2 over x2 is -1 minus the 4. And so you got your slope of 5 plus 2 over -1 minus 4 is -5. So you got a slope of 7 over -5. And we want to take that negative up top. So this has a slope of -7/5. Let's do another couple here. We've got -3, -2, and 5, -2. So here's that line going through those two. I'm going to name it x1, y1, x2, y2, and I'm also going to plug it into my slope formula. So we've got our slope here is y2 minus the y1 over x2 minus the x1. So I got -2 plus 2, which is 0, over 5 plus 3. So I got a slope of 0 over 8, which is a slope of 0. And notice this line is horizontal, right? This line here, I outlined it in red, is horizontal. It has a slope of 0. This line up here in black is going down and to the right. It has a negative slope, right? If it goes down to the right, negative slope. Let's do this last one here with x1, y1, x2, y2, and let's plug it in. y2 minus the y1 over x2 minus the x1. So I've got a slope of -6 over -3 plus 3. Well, we can't divide by 0. No, cannot do. So this slope is undefined. And that's because this, if you look at these 2 points, -3, 4, and -3, -2, this is a vertical line. So there's no, it's straight up and down. So the slope is undefined because the difference in the x values is 0. You can't divide by 0. So you have no value for the slope. It will be undefined. So here's a summary of that. This is if you have a slope that's positive. This is if your slope's negative. This is when your slope is 0. It's a perfectly horizontal line. And finally, if it's perfectly vertical, your slope will be undefined. Okay. Now, last time we also talked about the general form of a linear equation. We're going to use these two now, the point slope form. Whoops. The point slope form right there. This is useful when you have a point and a slope. Point and a slope. And we're going to use that to then solve for y and put it in this slope-intercept form, where m is your slope, b is your y-intercept. Okay, so let's write some equations doing that. Notice I have a slope and a point. I have a slope and a point. It goes through -2, -4. So here's my x1, y1. So I'm going to use point slope form to write the initial equation. Here's my point slope form. Y minus the y1 equals m x minus the x1. So y plus 4 equals negative 1/3 x plus 2. I'm going to go ahead and distribute that. Negative 1/3 x. Negative 1/3 times 2 is a negative 2/3. And then we're going to solve for y at the end because I want it in y equals mx plus b form, where m is the slope and b is the y-intercept. I have numbers for m and b, so I'm solving for y. So I subtracted 4 on both sides. So I got negative 1/3 x minus 2/3 minus the 4, though. This is 4 over 1. Get a common denominator. So I got negative 1/3 x minus 2/3 minus 12/3. Well, negative 2/3 minus 12/3 is negative 14/3. And see how I have it in that y equals mx plus b form? So I've written the equation of the line in slope-intercept form. Let's do it for this one. This time it's given us 2 points, x1, y1, and x2, y2. So the first thing is I need to have a slope as well as a point. So let's find the slope first. y2 minus y1 over x2 minus the x1. So my slope here is 1 plus 5. I got 6 over 2 plus 2 is 4. So my slope is 3/2. So now I know I have a slope, and I'm going to use one of these points. Either of the points is fine. And I'm going to plug it into point slope form because I have a point and I have a slope. Y minus the y1 equals the slope, x minus the x2. So y plus 5 equals, let me distribute that, 3/2 x. 3/2 times positive 2 is 6 over 2, which is 3. Let me subtract 5 finally to solve for y, so I have it in slope-intercept form at the end. There's our slope-intercept form. Now let's do one more here with these points, x1, y1, x2, and the y2. So we'll start out here with our slope first. y2 is a negative 5 minus the y1 is a negative 5 over x2 is 3 minus the x2 is a negative 2. So I got negative 5 plus 5. I got 0 over 3 plus 2, 5. So 0 over anything, 0. So I know I have a slope of 0, and I have a point. I can use either of these points as my x1, y1, and I'm going to put it in point slope form. Y minus the y1 equals slope x minus an x2. So I got y plus 5 equals 0 times anything, 0. So then we just solve for y. So y ends up being negative 5. So it's just that horizontal line. You know, if you're graphing negative 2, negative 5, and 3, negative 5, you should see that horizontal line right there, y equaling negative 5. Well, thanks so much for watching. See you next time.